on behalf of Elemental. And Elemental Technologies is a company that enables pay TV operators, broadcasters, content programmers, and enterprise and video customers to provision content to play on any screen and any device at any time. So today I'm going to go through a little bit of background on Elemental, and then some of the key trends and challenges that the market has faced over the past few years and is facing now. And then I'm going to walk through some file-based and real-time workflows, as well as live-to-VOD workflows. And then I'll go through Elemental Delta, which is Elemental's new video delivery platform, and how that's enabling and driving media monetization. And then I'm going to talk a little bit about leveraging the cloud. And then if we have time, I might get to disruptive technologies, but there are a few slides at the end there that actually Matthew covered earlier in his presentation. So Elemental is the leading supplier of software-defined video solutions for multi-screen content delivery. So what does that mean? So that means that if you have content, any sort of content, whether it be sports, whether it be entertainment produced by major studios, it can be government or enterprise applications, and it's taking this content and delivering it to any screen. So set-top boxes, smart televisions, tablets, PCs, mobile devices. And it's connecting viewers with this content at a massive scale across all kinds of networks. And so looking back at 2010, you had the market-leading brands like HBO and Comcast and the BBC. You had them focused on delivering to the TV set. Well, since 2010, and that's when the iPad was launched, no coincidence. So since 2010, these companies' initiatives has focused over to delivering to multi-screen devices. So HBO Go launched in 2010, and since 2010, HBO has seen millions of subscribers added, including over 2 million subscribers in 2013 alone. You have Comcast, which had its traditional on-demand experience. They spread that to multi-screen devices. And you have the BBC, and the BBC likes to push cutting-edge technology anyway, but they have their iPlayer, which is their digital media player, and that runs on thousands of devices. And in 2014, this is a little bit old, but in 2014, the iPlayer handled 3.5 billion program requests alone. So some of the key market trends and challenges. So we've kind of broken this down into the distribution space, into the platform of how that is being delivered, and then how consumers are consuming that content. So on the distribution side, the legacy distribution, you have coax, you have DSL, you have over-the-air, and that's kind of converging, as we're talking about this week, to an IP infrastructure. And then also you have hardware video delivery platforms, which are moving to software, which can run on appliances, on off-the-shelf hardware. It can run on virtual machine instances, or it can run in the cloud. So it's really whatever infrastructure you want to deploy, software-powered video is going to enable how you get your video out to your subscribers. And then you have consumption. So in the past, it was that TV set. And while TV consumption is still a big focus and very important, the future model is revolving around mobile, and this being the main screen that these companies worry about. So multi-screen video's exponential challenge. So in the past, the television provided a single experience and very defined standards, thanks to SMPTE, but defined standards, so these companies knew how to reach consumers, and the innovation was manageable. It was gradual, it was over time. Every couple years, a new standard would come out, but it gave companies, hardware manufacturers, time to create infrastructure to enable delivering to the television. Well, with multi-screen, now you are delivering to thousands of devices. And not only do you have all these devices, but you have all these different technologies, whether it's codecs, resolutions, bit rates, you have ad splicing, watermarking, time shift television, audio formats. And each of these technologies may be different depending on the type of device you're delivering to. So this is where you kind of see that becoming an exponential challenge. And so you have millions of experiences, you have de facto standards instead of these set standards. So you have Apple releasing one type of standard while Google's backing another standard. And you have this innovation that's occurring rapidly every couple months. And so you need, what our view is, you need a software infrastructure to be able to be upgradable, to be flexible, and to be able to keep up with this kind of exponential growth of video to all these different multi-screen devices. So that's where we come in. That's where Elemental comes in. Elemental has built software to process, package, and now deliver video to any screen, whether it be a tablet, a PC, set-top box, and we enable our customers to do that on-premise, or in the cloud, or in a hybrid model that is a balance between the two. So I'm going to go through a few workflows here. So starting with file-based and real-time workflows. So file-based video processing. That, for Elemental, that solution is Elemental Server, and it's a file in, and then one file or many files out. And so you have your transcoding system, you have a control layer, like a PC, which is able to access that transcoder through a web interface or a REST API. And then you have storage. That storage can either be on the transcoder itself, or if you have quite a bit of storage, quite a bit of files you're needing to process, that storage can be network attached so you can process a large quantity of files. And if you're creating mezzanine formats, then the storage piece is really all you need because you're saving your assets for later. But if you're delivering that video to multi-screen devices, that's where an origin server, a CDN, that delivery piece comes into play. So this is what Comcast Philly started out with. Comcast is, let's see here, I wanted to go through. So Comcast had their traditional delivery model through video on demand, and they wanted to make that available to their subscribers on all different devices. So what they did is they used Elemental Server, and they used the platform's MPX management system, video management system, to convert their entire content library and make it available on these applications. And so their workflow looked like this. They have a shared storage system, and so as a file asset comes into that shared storage system, the platform picks it up, tells Elemental Server to go get it and process it. Elemental Server then applies scaling, deinterlacing, any sort of image processing necessary, and creates all the adaptive bitrate outputs, which it then puts back into storage, and the platform then grabs those files and delivers them to Comcast CDN for distribution to multi-screen devices. Telefonica, which is headquartered in Spain but has operations all over the world, they have a similar sort of platform, what they call their global video platform. And they use Elemental Solutions to provide their file-based processing as well. And so it's not only video processing here, but it's a video management server as well. And that's Elemental Conductor, kind of providing what the platform provides for Comcast. And so Elemental Conductor can manage a whole cluster of file transcoders, Elemental servers. And Telefonica processes, as you can see here, 70 hours daily of HD and SD VOD content, delivering 12 MP4 adaptive bitrate outputs, as well as 11 Microsoft Smooth outputs for set-top box streaming. So if you look at a little more of an extreme file-based workflow, on the bottom here you have your deployment on the ground, and that is a redundant Elemental Conductor video management setup. You have your Elemental Server video processing platform. You have a redundant setup with that. And then you also have redundancy up into the cloud. And so you have another video management system, Elemental Conductor, talking to the Elemental Conductor on the ground. And what that allows is for customers to offload jobs from the ground to the cloud in the case of a spike in demand. And then in addition to that, you can also have a redundant cloud setup in multiple regions. So with Amazon, they have infrastructure in Oregon, Amazon has infrastructure in Virginia, and you can actually have multiple deployments in the case of a catastrophic outage. You don't want your operations to go down. You can fail over to another cloud region. So then moving on to live workflows. In this case, you have maybe a small amount of live content. You have one-off events here and there. And so what this looks like is just a source, whether it be ASI or SDI or IP, that comes into your encoder. And the encoder delivers it to the video delivery platform, where it then goes out to end users through a network like a CDN. And A&E Networks is a customer that is doing this. So they have all their VOD content that was made available for their end users, but they wanted to extend that to their live content. So A&E owns the A&E channel and also the history channel. And so they wanted to make this available in a linear setup 24/7 and also monetize it through dynamic ad insertion. So what they did is they used mDialog and Freewheel as ad insertion partners, as well as Elemental Live for doing the live processing. And so what this lets them do is it ensures the highest quality of video for their end customers and lets them access their content whenever they want. So in this workflow, in the A&E workflow, Elemental Live takes the SDI feed. It produces RTMP outputs. It outputs those outputs to the CDN using along with dynamic ad insertion with mDialog and Freewheel. And then that content's delivered to Akamai, where the RTMP is delivered to PCs. And Akamai also repackages that content to HLS for streaming to iOS devices. And the benefit with repackaging at the CDN is that you only need Elemental Live to produce one output. So instead of having Elemental Live produce all the HLS and the RTMP outputs and sending two versions of that video across the network, which can be expensive sending video across the network, if you package as close to the end user as possible, then you can save on bandwidth delivery costs throughout the video processing pipeline. And then looking at a little more of an extreme live workflow here, you can still see the source coming into Elemental Live, redundant Elemental Live setup here. You have redundant management through Elemental Conductor. And then you have your OTT delivery up here to multi-screen devices, but you also have your traditional delivery, live linear delivery down here. And so in what has been a workflow that has been fragmented in the past between traditional delivery and multi-screen delivery, these workflows can look pretty separate. What Elemental's focus on doing is really converging that infrastructure so that you're only using a single set of equipment to deliver your entire video workflow. All right, and then a couple other live workflow examples here. So you have a capture and record, and this is something that LA Dodgers do. So they, from the moment gates open till when they close at night, they'll do a capture of all their feeds for their Jumbotron and for their game operations, and they'll capture and record that content to ProRes in real time as well as MP4. And they have that ProRes as a high quality output for storage. And then they have the MP4s, which they can immediately distribute to any game day operation employees that need to see it for whatever reason. And this is also, capture and record is also a workflow that studios and post-production houses when they are moving tape content to a digital format. And then lastly, capture and edit is similar, except that when you're capturing and recording the ProRes, sorry about that. When you're capturing in ProRes, you can actually bring ProRes into a nonlinear editing program and create highlight clips while the original event is still taking place. So this is something that you might be familiar with MLB Advanced Media doing. So if you are tracking a game on MLB's game tracker called Game Day, and somebody hits a home run, you're able to see a replay of that highlight within a minute of it happening. And this is because they can edit the file while it's still growing and create these highlight clips and make them available. So this is really big for sports. It's really big for news. You really see it in all the major sporting events now: basketball, baseball, football does it, soccer with goal scoring. And Elemental Live, the ability to edit a growing ProRes file, is fairly unique in that sense. So, driving media monetization. So one of the challenges with next generation workflows is that you have all this digital content, but it's been difficult to monetize to date. And so that's Elemental's video delivery platform is trying to take on and address some of those challenges that we've seen so far. So with next generation content delivery, so you have a digital experience, you have your live experience, which you can see here on the left with Watch ESPN, and that experience is really dominated by the broadcast experience. You have your live content you can choose from. And then with on-demand content, that's really dominated by the subscription model. So with Netflix, you have the content that you're currently watching or recently watched. You have content that you've marked as content you'd like to watch in the near future. And then you have content suggested for you by Netflix based on your viewing profile. And so the challenge has been kind of bringing the live experience and the VOD experience together. So fusing that content experience. And this is what CNN launched late last year. It's their application called CNN Go. And you can see here, this is a fusion of their live content as well as VOD assets. And so on the top right, you have the video player, and that's what's playing on CNN Live. And then it has catch-up capabilities. So catching up means you can access programs that have recently finished, whether it's a few minutes ago, whether it's a few hours ago, a day ago. Clips that have finished you can access. And then also has start over capabilities. So maybe you came into the show halfway through and you want to start it from the beginning. That's where start over kicks in. And then you have on-demand clips, and these clips could be generated based on the content that's playing, so it could be relevant. So we have fun facts about volcanoes because it's a volcano content. You could have the news story about the same news story from the previous day. You've got still photos here that are related to the same story. And this content would change if I selected a different program from the Catch-Up TV menu here. So you can see it's a fusion of the live experience, but it's kind of catering to the viewers so that it keeps them engaged. It lets them select different content when they get bored of the content they're watching. Instead of going away to another channel, it actually keeps them within CNN. And going through some of those definitions again real quickly. So catch-up TV or replay TV is playing a program that has ended, whether it's a couple hours ago or a day ago. Start over TV is replaying the current show that's watching. NPVR is network-based recording as defined by the customer. So this is where you're not actually limited by a physical recording device. And then time shift television, and the best example of time shifting is you have the Today Show live in New York at 7 a.m. and then that show is replayed in LA at 7 a.m. and that's an example of time shift television. So the application overview for Elemental Delta here, you have Delta adding new value-added services and capabilities like the ones I just listed with Catch-Up TV, Start Over TV, and MPVR. It also has personalized advertising capabilities. So it can insert an ad based on what the end viewer viewing device is, or where that viewer is, or what they've watched previously. And it can also bring some of the distribution costs down by bringing that distribution piece in-house instead of paying a CDN to do the distribution for you. You can actually capture some of that yourself before distributing it out to end users. And one other thing with Delta is it lets you just encode once, and then like the A&E workflow I referenced earlier with repackaging to HLS, Delta will let you, so you can encode once with your encoder, and then Delta can package on the fly depending on what device is requesting that content. So you don't need to create all the different formats until they're actually requested by the viewer. So that can really save on storage costs. It can save on distribution costs. So applications with Elemental Delta. And the first application here is similar to what I just mentioned, but an example here is having the live source ingested into Elemental Live, the encoder, having Elemental Live produce a single format out, which is ingested and stored encrypted by Elemental Delta. And Elemental Delta just keeps it until it's actually requested by the device, at which point it takes that content, decrypts it, repackages it for that end device, and provides any necessary DRM or encryption, and delivers MPEG-Dash to set-top boxes or televisions, HDS or Microsoft Smooth to PCs, or HLS to mobile devices as an example. The second application is dynamic ad replacement. So what's interesting here is not only can Delta detect what kind of device is requesting the video and insert the ad based on what kind of device that is, where the viewer is, but it's also, this ad insertion is done server-side instead of client-side. So client-side ad insertion is where the video player on the mobile device reaches a point in the program where it needs to go and get an ad. And so that can kind of disrupt the user experience because it reaches a breaking point. It has to go request the video. It may need to load. And it also is very susceptible to ad blockers. So if you've gone to YouTube and you're watching a piece of content, you're used to that 15 or 30-second ad at the beginning. But if you have a pretty solid ad blocker, the ad blocker will get rid of those ads right away. And so for broadcasters, news organizations that want to monetize their content and need to really make a case that this advertising space is useful, these ad blockers are really detrimental. And so the beauty with server-side ad insertion is that the ad is inserted at the delta point, and that's then delivered to the end user device, and it looks like a single stream. And not only is that good for the viewing experience, but it also doesn't make it susceptible to ad blockers. And then the end-to-end encryption workflow. So this use case is if you're distributing premium content and you really need to make sure that content is locked down, whether you need to comply with an SLA. If your content gets ripped off, you could be in a lot of hot legal water. So Elemental Live, the encoder, can produce an AES encrypted stream, which is then stored by Delta, and Delta can do on-the-fly decryption and re-encryption to end user devices. And though the content is protected using AES 128, this is a standard form of encryption, so it doesn't actually need to be an Elemental product to do the decryption. It's a very standard form of encryption. So as long as the origin server can decrypt AES 128 or the encoder can produce AES 128, that content can still be processed all the way through the video processing workflow. Yeah.
Can I ask you to go back to the previous one that you said one thing? So
Yeah.
in a situation like this, though, if you're trying to deliver those outbound streams with the ad inserted to a huge number of viewers, you still want to go through a CDN, right?
Yeah.
So do you then send the CDN the different
You would still do the ad insertion at the origin and use the CDN just to feed it all the way through, just because they have so many points of presence and can.
Right. But part of what you were saying was useful about this is that the delta can detect what type of user it is and target a specific ad.
Mm-hmm.
So in that case, if you're going to the CDN, you've now moved back a space from where the end user is.
Yeah, and I think so. Delta is an origin server, but it will also have edge capabilities.
Okay.
And I think that's where the client side comes into play, talking to the client.
Okay. But you wouldn't want, if the people at the far end of the CDN have different kinds of devices, if you're trying to serve them specific ads, presumably you have to have multiple Delta servers.
You.
Like pulling a different file type because it's IP multicast, so it's driven by goes upstream.
But in that case, all of those different streams have to go to the CDN, and then the CDN parses them out to whether it's an iOS device.
Right.
But I think we're getting into an IP multicast lecture, which is kind of
Maybe, I'm just trying to understand.
yeah, no, it makes sense. I mean, unless you have time to get into IP multicast.
No, I
as
just
an
want to
architect.
understand the concept of what you're talking about. Okay.
Yeah. Okay. Well, we can maybe talk after a little bit too. And then I just want to talk a little bit about cloud and IT-centric models, and I know the next presentation is going to cover cloud quite a bit, but is cloud processing viable for video processing? And so what we have here is what we put together as the demand prediction challenge, and you can see the dotted line is the amount of video processing that you think as a company you're going to have on a day-to-day basis. And you acquire enough infrastructure, seen here in the step chart, to meet this demand and also keep overhead in case of fluctuation. So the white wavy line is what actual demand might look like if it's not a perfect trajectory. But the problem here is that, one, you have, in the light gray, you have all this excess capacity. So there are idle resources going unused at any given time, where you have transcoding systems that aren't being used. But also, another problem, and a more serious problem, is that even though you keep this excess capacity, this overhead, it doesn't always keep up with actual demand. So you see the small dark gray pieces here. That is where demand is actually exceeding capacity. And when that hits, you can't fulfill your video processing obligations, and that can be a real problem for video content programmers. So what the cloud enables you to do is it lets you only acquire enough hardware as necessary to take care of your 24/7 transcoding requirements. But anything above that, you can take advantage and leverage elastic cloud resources to meet actual demand. And so what that does is it really optimizes your expenses, and it also, in the case of big spikes, it lets you scale up dynamically to meet this increased demand. And so that's kind of what a cloud bursting hybrid model looks like. You have your storage system which can either be in the cloud or on-premise. You can have elemental conductor managing on the ground and in the cloud talking to each other. And then you have your server cluster on the ground doing day-to-day transcoding tasks and then offloading as necessary to the cloud. And that can be based on rules. It can be the number of jobs you have in the queue, whether those get moved up to the cloud or not. It can be where those assets are. So if you have storage both on the ground and in the cloud, you can set up rules where only cloud stored assets get processed in the cloud and assets on the ground get processed on the ground. And one of the customers that is doing this is the platform, and the platform is a subsidiary of Comcast. And Comcast is obviously a major focus of theirs, but they had built a pretty robust video management platform, so they were looking to expand their video management offerings to other leading media and entertainment companies. And they decided to leverage Elemental Cloud for this is because they had some some time-intensive opportunities that needed to get them up and running as quickly as possible. And so cloud let them expand to new markets very quickly, and also utilize their on-premise encoding infrastructure. And BBC Video Factory did sort of the same thing. So they had their on-demand product service, but it had a maximum capacity of 40 hours of HD video a week, and that wasn't enough to meet subscriber demand. They were falling behind on getting their shows up and available for subscribers. And so that resulted in a significant delay in posting these catch-up assets. And so they decided to move to a cloud-based infrastructure as well. And so what that did is the processing capacity was no longer a blocker. They got their live programs up on demand much faster. And they can also adapt as new devices come out and they want to add their iPlayer support to those new devices. So one of the things I also wanted to mention here is that the purchasing model between on-premise and cloud is also very different. So, you know, some challenges with companies is that you might have a certain amount of capital expenditures you can spend per quarter or per year, and once you hit that wall, it's tough to be able to scale up and get new on-premise infrastructure. But if you are able to leverage the cloud for video processing, this is an operating expenditure, and there might be a little more flexibility within your business to be able to add these models. So just going through the BBC workflow, so they capture live broadcasts, and it's a live-to-archive capture, and then these archives are in the cloud where they're then picked up by any idle instances in the cloud, and it can scale up and down elastically as necessary, so they're not using excess capacity, they're not using any instances that they don't need. And cloud processes multiple adaptive bitrate streams, and again, yes, it ramps dynamically with processing demand to get to these end user devices. And this slide just shows a high availability workflow. And so what this is it's Elemental Live on the ground acting as a contribution encoder. And what it can do is take in the IP input and encode HEVC in real time up to the cloud to save bandwidth while maintaining quality. And then in the cloud, that's where the adaptive bitrate sets can be created. And you see all these crisscross arrows. That's for redundancy, high availability, making sure the workflow never goes down. And so a couple example customers for this are the platform, as I mentioned. And this workflow was similar to what EVS did last year for the 2014 World Cup. So EVS, they were tasked with live streaming the World Cup in 12 different venues across Brazil. So Brazil's a big country. They had all these different venues. They had to stream games live, and there might be 4 games at once, or there might have been 1 game at once. And so what they could do using cloud was provide an end-to-end second screen solution for live streaming and multiple camera angles for the end customers. And so they created this adaptive set of outputs using cloud, outputted those to the broadcaster's CDN of choice, and then the broadcasters, each national broadcaster could decide which streams to make available to their users. So again, this just kind of walks through that. They used Aspera to make sure the content got to the cloud quickly, efficiently, and cleanly. They did the cloud processing while applying scaling and deinterlacing and other image processing capabilities. And they created all the different formats they needed for the broadcasters to distribute to the viewers. So I wasn't actually planning on going through these just because Matthew covered some of them. HEVC is something we're starting to see, especially within workflows, since it hasn't really been added to end user devices yet, but it's being used within workflows to get from one encoder to another encoder, that sort of thing. HDR, Matthew talked some about that. 10-bit color depth, same sort of thing. And then these are just some of the 4K streaming innovations that LML's participated in, starting with the Osaka Marathon was the world's first real-time 4K P30 HEVC streaming. Sochi, in the Winter Olympics, there was quite a bit of 4K streaming done. Comcast used that to stream to 4K to set-top boxes. And then IP and satellite streaming over 4K, using 4K. And then again, the World Cup last year. And companies, satellite providers are starting to look at 4K VOD rollouts for their subscribers with 4K TVs. So that's about it. Again, software-based video is where we think the market is headed, and that's really what we're getting behind as a company. And that is software that's deployed on the ground, in the cloud, or a hybrid between the two. And that's video processing, it's video delivery, it's getting content to subscribers on any sort of device, whether it's a traditional delivery model or on their multi-screen devices. So with that, I can open it up to questions, or depending on time, running late. You can find me also. Barry Lauer is here. He's also with Elemental, so we're happy to answer questions. My contact information is in this deck as well, which I believe you'll all be getting, so you can reach out to me and I can forward questions along to technical resources or account managers. So thank you very much.